So let us spend some time today to solve the objective questions that normally appear on control systems. We have discussed few topics in the previous classes and what kind of questions we can actually generate and we can expect in competitive exams. So the question 1, components are objects connected together to serve an objective. 4 options are given. Option A, system, option B, control system, option C, machine, and D, none. So here the components are connected to perform certain objective. So obviously it is a system, and that system may be a electrical system or mechanical system. So option A is the answer for this. Question 2, arrangement of physical components to give desired output for a given input by means of control or regulate. So compared to the previous question, here you can expect the desired output. So desired output can be expected from control system. System, control system, plant, and none. So when you expect desired output, it must be a control system. So option B is the right answer for this. The question 3, the part of a system which is to be controlled or regulated. What is it? Is it a controller, plant, or input? So generally any control system is represented like this. It will have a controller, then there will be a plant or process, then output. So here the part of the system, these are the components of a control system. So the part of a system which is to be controlled or regulated is a plant. So the example for this plant, it may be an iron box or washing machine, etc. So the options are controller, plant, input, and none. So the correct answer is plant. So this is to be controlled by the controller. So option B is the right answer. Question number 4, investigation of properties of an existing system. System is already given to us. Now you need to investigate, study the properties or characteristics. So what is it known as? Options are design, analysis, synthesis, none. So analysis is the right option because system is already existing and you are just studying its behavior. So option B is the right answer for this question. Question number 5. It is the extension of the previous question, that modifying the characteristics of an existing system. What is it known as? Is it design by analysis, design by synthesis, none? So 3 options are given here. So modification is possible only when you study first, then it is called actually design by analysis. So option A is the right answer. This is design by analysis. The question number 6, defining the form of a system directly from its specification. So you are not actually studying the characteristics of an existing system here. Specifications, based on the specifications, you are just trying to directly design it. So what is it known as? Options are A, design, B, design by synthesis, C, design by analysis. So the correct option here is design by synthesis, option B. The question number 7, linear control system. It should obey the principle of, options are superposition, homogeneity, and both superposition and homogeneity. So any linear control system, it must obey both principles, superposition as well as homogeneity. So the correct option is here C. Any linear system must obey superposition principle and then it should have homogeneity also. Question number 8, coefficients of differential equation are constants for which system? Options are time variant system, time invariant system, both. In fact, it was explained in the previous classes that any system can be described by a mathematical model. It is a differential equation. However, this differential equation will have coefficients. That coefficients are constants, then it is a time invariant system. If the coefficients are variable, then it is time variant system. So here option B is correct answer, that TIV system means time invariant system, and option B is the right answer. Question number 9, systems in which the control action is independent of the output. Basically, the control system is represented like this. So you can see there is a controller, this C referred to controller here. So action of this controller is not depending on the output. So there is no feedback here. So the action of this controller depends only on the input but not on the output. So the options are here: A, control system; B, open loop control system; C, closed loop control system. So the correct option is B. It is an open loop control system. The loop is not closed. It is open because action of this controller is independent of the output. So B is the correct option. Question number 10, system in which the action of the controller depends on output. There is a controller even here also, but action of this controller depends on both input as well as output that is taken as feedback for reference. So this controller action is depending both on input as well as output. That's why it is called closed loop control system or feedback control system. There is a feedback that is actually taken for the measurement of output. So option C is the right answer. It is closed loop control system or feedback control system, option C. Some examples have been given here. Question number 11, fan without a blade. So fan without blade is a system or not a system or control system. So no blades, then no function. So it is not at all a system. So option B is the right answer. Fan without blade is not a system at all. Question number 12, fan without a regulator. As you know, the function of the regulator is to change the speed of the fan. So is it called a system or not a system or control system? No doubt it can still function. Fan can function without regulator also. Of course, you cannot have regulated speeds, variable speeds, but one speed the fan can work without regulator. So it is a system. Definitely it is not a control system because there is no parameter that is to be controlled. So fan without regulator is a system. Option A is the right answer. Question number 13, fan with regulator. Now what is it known as? Is it a system or control system, open loop control system or closed loop control system? Fan without regulator is a open loop control system. So option is 3 here, because there is no feedback, there is no sensing mechanism in this case. There is a regulator to change the speeds, but it is not measured. Speed is not measured at what speed it is running, but still it is a control system and it is an open loop control system because there is no feedback of the speed. So option 3 is the right answer. Now fan with regulator, question number 14, and a speed sensor. There is a sensor and that sensor will measure the speed of the fan. So it is called as a closed loop control system. In the previous question we have seen it was without sensor. Now there is a fan, of course regulator, but also speed sensing mechanism. So 4 options are given: system, control system, open loop control system and closed loop control system. So the option D is correct here because there is a sensing mechanism. Now coming to this, which systems are economical and simple? The question comes, when do we say that system is economical? Because the number of components involved in the system, if they are less, we say that it is economical system, and it is simple, means no complexity involved in this. So open loop control systems, option A is the right answer because there is no sensor in this open loop control system, no feedback measurement, etc. So it is economical as well as simple. That is the advantage of open loop control system. So option A is the right answer. This is 16th question. Which systems are accurate and reliable? So what is that you are expecting from the system? You want to have an accurate output, no deviation, and precise output, we say, and reliable output. So these two are the characteristics of closed loop control system: accuracy as well as reliability. So options are open loop control system, closed loop control system, and both. So option B is the right answer because closed loop control systems are accurate and reliable, though they are costly. Question number 17, systems that are less sensitive to the parameter variations. Again here, among the two, open loop or feedback control system. So because of the feedback, the plant output, it is always accurate. So external parameters like temperature, humidity, etc. cannot influence the output of the plant. So because of the feedback, that's why systems are less sensitive, means more robust to the parameter variations. No parameter can influence the closed loop control system. So the option B is the right answer for this question. Question number 18, the common nonlinear effects in control system: saturation, backlash, dead play, and all of the above. In fact, all these A, B, C are the nonlinear effects in control system: saturation, backlash, and dead play. So the option D is the right answer. Question number 19, gain of feedback control system is reduced by what factor? As you know, the open loop control system gain is given by G because there is no feedback, etc. And whereas the closed loop control system, when you have G by 1 plus GH. So you can see that the gain of open loop control system is this and closed loop control system is this. So the change is this much. So closed loop system, the moment you connect the loop, the gain of the system is reduced by a factor by 1 by 1 plus GH. So among the 4 options, C is the right answer because the gain is reduced here. That's why in closed loop control system, you must have a controller which can increase the gain of the system. Question number 20, the gain of open loop system is, as I indicated in the previous question, there is no feedback. So the gain of such open loop control system is simply G. This is nothing but forward path transfer function or open loop transfer function because no H involved here. So the answer is G, and option A is the right answer for the gain of open loop control system. This is another question, that sensitivity is one of the characteristics of closed loop control system. So the question is, sensitivity due to feedback is reduced by a factor. Closed loop control systems, as I said, they are less sensitive to the parameter variations. So it is reduced by what factor? It is represented by sensitivity and of the system given by the transfer function with respect to G. So if any variation is there, if any parameter try to influence the system or plant, then that effect is very less in the case of closed loop control system, because it is reduced by a factor 1 by 1 plus GH. That is the advantage of closed loop control system. They are very less sensitive to the parameter variations. No parameter can influence the closed loop control system. So the option B is the right answer. Now coming to the standard test signals, the questions that are related to the standard test signals in the control system, I indicated that step signal, ramp signal, parabolic signal and impulse signal. These are the inputs to the control system used in the laboratory, but actual inputs to the control systems are sudden change, sudden shock, constant velocity and constant acceleration. So here the question is, which of the following signal resembles the sudden change? There is a change from one value to another value. So this situation arises in any control system. It may be a temperature control or mechanical system or thermal system or electrical system. There will be a sudden change. When you are increasing the voltage from 10 to 20 is nothing but sudden change. So which signal resembles sudden change? Options are step, ramp, parabolic and impulse. So sudden change means, say it is 0, so there is a change from 0 to 1. So this is the signal represents sudden change in control system. So this is, if it is 1, we say it is unit step. If it is some parameter A, say, then it is simply a step signal. So option here is A, because sudden change means it is a step input that is used in the laboratory to test any control system. Now the next question is, which signal resembles sudden shock? Shock is something undesirable. So there must be a signal available in the laboratory to resemble this sudden shock characteristic, that is impulse. Impulse is the signal that is undesirable signal. It has a very high magnitude in 0 time. There is a signal at 0 of infinite magnitude and no signal at t greater than 0. So this is called sudden shock. So out of the 4 options, sudden shock is nothing but it is an impulse signal. Impulse signal, option D is the right answer. Now the next question is 24. Which of the signals resembles constant velocity? So here the constant velocity is the signal. It will be like this, a linear increase. So this is nothing but a ramp signal. Ramp signal, and whose magnitude is given by AT. If it is a unit step, it is simply AT. So as time increases, the signal value also increases. That's why it is a linear increase. So constant velocity means a ramp signal, and option B is the correct answer for this question. Now question number 25. If the amplitude of impulse is A, then what is its time? So it is difficult to generate the ideal impulse, because impulse ideal is high magnitude in 0 time. So it is impossible to generate the ideal impulse. So generally it is defined like this: a very high magnitude, say A, high magnitude in time 1 by A. The impulse is defined this way: if the amplitude is A, very high magnitude, then its time should be very, very less, that is 1 by A, so that the area of this signal is 1. So the time that signal exists, which very high signal that exists for a period of 1 by A seconds. So the option C is the right answer. Now there is a definite relation that exists between all the four signals. It was given in the previous class that there is an impulse whose Laplace transform is 1, and the step signal, if it is unit step, it is 1 by S. If it is unit ramp, then 1 by S square. If it is unit parabolic, it is 1 by S cube. If it is not unit, then this may be A by S, this may be A by S square, this may be A by S cube. So there is some relation exists. You can see 1 becomes 1 by S, then 1 by S square and 1 by S cube. If you go this way, the relation exists between all the four signals. So impulse function is the derivative of which function? Options are ramp, step and parabolic. So correct option is B. So unit step Laplace transform is 1 by S, otherwise it is simply 1. So the derivative of unit step is an impulse signal. So option B is the right answer here. Impulse function is the derivative of step function. Question number 27. Step function is the derivative of again ramp function. So the ramp is represented like t in a time domain, and parabolic is represented by t square by 2, and this will be 0 because impulse function is high magnitude in 0 time. So this is generally represented as a delta of t, and it is t1 to t1 where t1 is tending to 0. That way impulse is defined. So 27th question, step function is the derivative of what? So the option B, it is a ramp function. So derivative of ramp function is step, that is d by dt of t is 1. That way you can see in the time domain or even in the Laplace domain. So correct option is B, step function is the derivative of ramp. Now the question number 28, just reverse of the previous question, that step function is the integral of what? So again here integration of that integral of impulse is a step function. When you integrate, there will be denominator in the s will appear. If you integrate step, it will become 1 by s square. If you integrate ramp, it will be 1 by s cube. So step function is the integral of impulse. So option B is the right answer. Question number 29, a simple definition, that ratio of Laplace transform of output to the input. Generally we know that efficiency is also termed as ratio of output to the input. So it is not like that because here Laplace transform is taken. So transfer function is the right answer, and option B is the correct answer for this. Question number 30, impulse response is nothing but, as you know that if I say R of s for impulse, it is equal to 1. The transfer function is known as C of s by R of s. So when I say R of s is equal to 1 here, then this C of s is nothing but impulse response. impulse response. So it is nothing but which one? The options that are given. It is nothing but transfer function. So the transfer function is nothing but C of s by R of s, and say it is T of s. Because of impulse input R of s is equal to 1, C of s is nothing but impulse response. So transfer function and impulse response both are one and the same. So impulse response is nothing but the transfer function. So option A is the right answer. Again, the transfer function is defined for question number 31 for which system? There is a limitation of transfer function because it cannot be applied to the time varying systems, non-linear systems, multiple input, multiple output system. So this transfer function concept, with certain assumptions, it is applied to linear time invariant systems. So among the options, option B is the right answer. Transfer function is applied to linear time invariant systems. Now, question number 32. The Laplace impedance for inductor L is, options are L by S, Ls, 1 by Ls, Ls square. As I indicated in the previous class, if there is a resistance R, then for Laplace this resistance appear as a resistance only. If it is an inductor, L, then Laplace transform of inductance will be Ls. It is known as Laplace impedance, and that's why Ls is the impedance, Laplace impedance, whereas L is inductance. So wherever you find L in electrical circuit, so for analysis purpose that inductance can be replaced by Ls, because this voltage across the inductor is L di by dt. It is nothing but L into S into I of S. No initial conditions here. So I0, current in the inductor, is ignored in the case of transfer function analysis. So this Ls is the Laplace impedance for inductor. So option B is the right answer. Now question number 33, the capacitance, how Laplace is seen in electrical systems. So Laplace impedance for capacitance C. As you know, capacitance is represented like this, and 1 by C integral I dt. This is the voltage across the capacitor. So when you apply Laplace transform to this becomes 1 by Cs into I of S. So the Laplace impedance for capacitance is this, 1 by Cs. So option B is the right answer. Laplace impedance for capacitance is 1 by Cs. Question number 34. Impulse response of a system decays to 0 when system is stable, unstable, marginally stable. Stability of the system actually defined in two ways. One is, for a bounded input, the output should be bounded, or else the impulse response of a system must decay to 0 as early as possible. Then we say that that is a stable system. So in terms of impulse response, stability was defined. So when impulse response is decaying to 0, it is good symptom that when it is decays to 0, so stable system. Option A is the right answer. If impulse response of the system will have sustained oscillations, then we say it is a marginally stable system. If it is not decaying to 0, but it is increasing exponentially, then it is an unstable system. So that way impulse response will be the reference for any system to be defined whether it is stable or unstable or marginally stable. So option A is the right answer, because for a good system impulse response must decay as early as possible. Now The question number 35, the time constant of the system G of S is given by 1 by S plus 10. As you know that this is given in the form of pole 0 form, that pole is located at S is equal to minus 10. Now, if you want to represent this system in time constant form, then what we do is 10 is taken out. So, 1 plus S by 10. So, this is 0.1 by 1 plus S by 10 means this is now the time constant form 1 plus tau S. So, the time constant of this particular function is 1 by 10. So, whenever it is given this way, even in the pole 0 form, you can just see that what is the pole, where is it located, and reciprocal of that. Reciprocal of that is a time constant. So, tau is equal to 1 by 10, that is 0.1 seconds. The meaning of this is the system response. If it is an impulse response, it will decay. You can come to know from this 1 by S plus 10. So, Laplace inverse transform of that is e power minus 10t. So, it will definitely have exponential decay, and then we say that it is a stable system because the pole is located in the left half of the S plane. However, and this e power minus 10t means the waveform will exponentially decay. However, the time constant is to be calculated the reciprocal of this pole that is located. So, option C is the right answer here. The question here is Laplace transform of e power minus at sin omega t is. 4 options are given here. If it is a sin omega t, Laplace transform of this is omega by s square plus omega square. So, when you have e power minus at is added to this, generally you know that e power minus at is 1 by s plus a. Now, these two are combined. These two are combined in the question that what is the Laplace transform of this e power minus at sin omega t. So, obviously in the numerator there is no change, but instead of s you will have s plus a because of the exponential term. So, it is s plus a whole square plus omega square. So, the option A is the right answer for this question. This is sine wave, sine function. This is exponentially decay function, and when both are combined, we say that it is a damped sinusoidal wave. Means you know that sin omega t means it has oscillations, sustained oscillations like this. Exponential decay means you know that it decays like this. When you combine both of this e power minus at sin omega t, then you have waveform like this. Combining exponential decay with sinusoidal sustained oscillations will be having damped oscillations. So, option A is the right answer in this problem. Now, question number 37, transfer function of RLC series circuit. V0 of S is the voltage across capacitor, Vi of S is input voltage. With R equal to 0, L equal to 1 Henry, C is equal to 1 Farad. It was actually given the transfer function of an RLC series circuit is 1 by LC S square plus R by LS plus 1. So, when you substitute R equal to 0, L equal to 1 Henry and C equal to 1 Farad, you will get this transfer function as 1 by S square plus 1. So, you can actually see that the correct option with R equal to 0 is 1 by S square plus 1, and option C is the right answer. Now, for impulse input, what is the output in the above problem? You have got the transfer function in the previous problem as 1 by s square plus 1. Now the question here is, what is the impulse response V0 of t for impulse input? Means this Vi of s is 1 now. Then what is inverse Laplace of this? So it is V0 of t, means you need to have inverse Laplace of this particular function. So if you remember that if it is omega by s square plus omega square is sine omega t. So you can see that omega is 1 now, because numerator is 1 and here also it is 1. So instead of sine omega t, sine t, because omega equal to 1. So the correct option is B, V0 of t is sine t. The question number 39, if the forward path gain is reduced by 10% in each system that are given here, one is open loop control system whose gain is given as 10, and in other case also 10, but it is a closed loop control system with the feedback 1. So this 10 is G and h of s is 1 in the case of closed loop control system if the gain is reduced by 10%. So this 10 itself is given, so there is a reduction in the gain. Then what is its effect on the output of open loop control system and in the case of closed loop control system? So the effect is dominating in open loop control system, it is 10% because reduction is 10%. Whereas in the case of closed loop control system, you have 10 by 1 plus 10 into 1. So the effect is very less here. So it is 1%. So closed loop systems are better here because they are not influenced by any variation in the system parameter. That's why option A in question number 39, option A is the right answer, 10% and 1%. Question number 40, there are two block diagrams that are given. The figure 1 is a open loop control system and whose transfer function is given by s plus 2 by s plus 1. For the second diagram, it was actually given k as well as 1 by s plus 1 in the second diagram. So it is also a open loop control system, but the path is this way. For the second diagram, it is k by s plus 1 gain in one particular path and 1 is also there in another path. So this is for one diagram, second diagram, this is for the first diagram. So here the question is, when do you say that these two figures are said to be equivalent, and for that what should be the value of k? So equate this function to this one, 1 plus k by s plus 1 is equal to s plus 2 by s plus 1. So you can actually see that now what should be the value of k so that I can say that these two are equal. So here it is s plus 1 plus k by s plus 1 is equal to s plus 2 by s plus 1. So obviously k value should be equal to 1 so that these two systems will be equal. So in the case of question number 40, option C is the right answer. Option C is the right answer. This way also the questions will appear. Both systems are mentioned. One is simply open loop control system. The second one is also open loop, but there is a feed forward path element of unit gain is also connected in the second diagram. So in such cases, you may ask the question like, what will be the value of k? So equate both the gains and then evaluate for k, and option C is the right answer. K will be 1 so that both are said to be equivalent. Question number 41. Impulse response of unity feedback control system is given as C of t, that is equal to minus t e power minus t plus 2 e power minus t. Now the question is, what is the open loop transfer function? That means g of s. So when I say that this is an impulse response, we can see that what is its C of s. Its C of s is, as you know, if it is e power minus t, it is simply 1 by s plus a, but because of the t term here, minus 1 by s plus 1, because coefficient is 1 here, whole square plus 2 by s plus 1. This is the Laplace transform of that. You can simplify this, s plus 1 whole square 1 plus 2s plus 2, and this is minus 1. So 2s plus 1 by s square plus 2s plus 1 is the closed loop transfer function, because it is C of s by R of s. Because R of s is equal to 1, this is an impulse input, because this is impulse response what you got. Now what is its open loop transfer function? Remember, if it is a unity feedback control system, I can write this as g of s by 1 plus g of s is given by this. Now the question here is, what is its open loop transfer function? That is, he wants only g of s. He wants only g of s in the question number 41. 4 options are given. Now you can always remember that when you have a closed loop transfer function like this, to get g of s, you need not do much calculations. What you can remember is this numerator term you can write here in the denominator. You can subtract this numerator term from the denominator, that is 2s plus 1 as it is, and in the denominator s square plus 2s plus 1 minus this numerator function, that is 2s plus 1. So it becomes 2s plus 1 by s square. So option B is the right answer here, that C of t, impulse response is given, then what is its open loop transfer function? It is given by 2s plus 1 by s square. Option B is the right answer.